আচ্ছা, তো অ্যাডিশনে প্রথমে additionটা I think you all know the rules of addition and you know that how do we do the addition, and as you also know this, but I want to give you a actually a recap about addition, then you can understand that what does it do and how do you do this. And first of all, I want to introduce yourself with a decimal addition, which is very common to you. Decimal means if I add 1 7 and 7 6, okay, you can do one thing. When you do not actually talk, you can mute your microphone, then the sound will not come, and if you want to talk, then you can unmute yourself. Okay, but as it's a one-to-one class, one-to-one discussion, most of the time you have to keep unmute just to interact with me. So 7 and 6, if we add them, the two digits, what do we get? 7 plus 6 equal to what? Can you tell me, sir? 7 plus 6 equal to 13. So I do is as my rough 13. Okay, but can I write 13 as my result? Can I write 13 here as my result?
No, sir.
No, just because of I know this, in decimal number system, there are only 10 digits. This is from 0 to 9. There is nothing called 13 in decimal number system, so we cannot write them. As we cannot write them, what do? We subtract the base of the decimal. We subtract what, sir? We subtract the base of the decimal, and if we subtract the base of the decimal, we get absolutely what? 3. Okay, sir, we get 3, and we write it as a result. And the technique that I am following and I am teaching you, this is that if I get this 3, that I got this 3, but this is not a normal addition. I have to subtract it this like for once. If we subtract it for once, my carry is what, sir? Can you tell me what's my carry?
Yes, sir.
If
1.
I subtract for once, my carry is 1, and this one will go where? This one will never be lost. This one will come into this lower position. I am giving us it a circle, surrounded it by a circle. You do not need to write this in the exam hall on your exam paper. I just give you for write this for understanding. So this one is my carry, and it will come to the next digit at the lower position, and 7 plus 1 equal 8, and 8 plus 1 equal to what, sir? 9. So can I write 9 here?
Yes, sir.
I can write, because 9 is present in decimal number system. I know that there are actually 10 digits, and 9 is one of them, and this is why we can write 9, and this is the addition. So do you understand this process? This is very much actually known to us that we do this, but from your childhood you actually experienced this addition, but you didn't actually follow this way. They taught you this carry is 1, and carry will come to this digit, and you have to add them. But this is the process that I am showing you, and this single process will be applicable to each and every number system, to add the numbers in each and every number systems. So decimal is a very easy one, but it will never come in exam. I am going to other additions like binary, octal, or hexadecimal. Okay, so what about the binary number systems addition? Okay, as we know that there is nothing without 1 and 0 in binary. If we do the addition in binary number system, suppose 1 0 1 and 1 1, this is the binary addition. I have to add the two numbers in binary number system. So if we add in normal number system, this part is for rough, I'm doing this as a rough or draft. As we add 1 plus 1 in normal number system, what do we get, sir? 1 plus 1 gives me 2. Oh, I want to write 2, but unfortunately I cannot write 2 just because of 2 is not present in the binary number system. Only 1 and 0 is available in binary number system. As we cannot write 2 here as my summation, what can I do? I have to subtract what? the base of the number system, the base of binary, and the base of binary is 2. So if I subtract 2 from 2, I get a big 0, a big 0. So big 0 is my what? Result. I write this result here. But I didn't get the 0. Normally I got the 0 by subtracting, and subtracting for how many times? Subtracting for once. Here is the 1. This 1 is my carry. This 1 is my what? This 1 is my carry. So this 1 will come to this lower position, and 1 will be added to this one, 2, and 2 plus 0 is actually 2. So I write 2 in my rough, and I cannot write 2. That means I have to subtract 2 from 2. I get a 0. This is my result. And as I subtracted it for once, this 1 is my carry. This 1 will come to this position, and 1 will be added to this one, and it gives me what? 2. Once again 2, but I cannot write 2. So I subtract 2 from 2. I get a big 0. 0 is placed here, and as I subtracted for 1, this 1 is my carry, and 1 will be placed at the at this position. As there is nothing, 1 is placed here. As there is nothing, 1 is placed here. Okay, without doing any kind of addition. So this is the result. So do you understand, sir, this process?
Yes, sir.
Okay, is it easy or super tough? Or rocket science?
Easy.
It's very easy. So if you understand this, believe me, all of the addition in all number system is completely done. So you can do any addition if you get in your exam. I hope you understand. So okay, now I go for another number systems addition. This I want to go for octal number systems addition. And what's this? Octal. And after that I will give you one for your practice, that I will check that whether you got it or not. In octal number system, suppose I add two numbers as like 420 with 7 6. So if we add 6 and 0, we get what? We get 6. We get 6. So can I write 6 here? We write 6 here just because of in octal number system there are 8 digits from starting from 0 to 7. Starting from 0 to 7. So this 6 is present in octal number system. So we write this. Whatever the next digit, 7 plus 2. 7 plus 2 gives me 9. So whenever I want to write 9, it reminds me that in octal there is nothing called 9. There is only 0 to 7. These 8 digits are present in octal number system. So we cannot write 9. We have to subtract 8 from 9, and we get 1. Why do we subtract 8 from 9? Can you explain me? Why do you subtract 8? Why not 7? Or why not other digits?
Because 8 is not present in octal number system, that's why we have to subtract it. Sorry, 9 is not present in octal number system.
Actually, I got the result 7 plus 2 equal to 9.
So we have to subtract the base of the
base. We subtract actually 8 from 9 just because of 8 is the base of the octal number system. Okay. So as I subtracted it for once, I got the result 1. This 1 is my result, and as I subtracted it for once, this 1 is my carry, and this 1 will never be lost. This 1 will come here, and this 1 will be joining to this number, and 1 plus 4 gives me what? 5. I can write 5 because 5 is present in octal number system. So now I want to give you an addition for your exercise purpose. Let's write the number on your copy and tell me the answer.
So is it in octal number system?
Yeah, it's in octal number system, right, sir? It's an octal number system. In exam you will be asked for doing the addition, and there it will be mentioned also that which number system you have to do the addition. So don't be panicked about this. Okay, it's for your exercise purpose. I'm pausing the record and I will resume it after I got your answer. Okay, you told this is 2. Can you repeat? What did you say? 296.
What's এখানে তো আসছে এটা আবার কোন
হ্যাঁ স্যার
স্যার এক মিনিট
confused about the answer. Yeah, you are confused on the answer. You say what's it? 316. You say the answer. 316. Okay, let me check whether you are correct or incorrect. Okay, no, don't be panic. The 7 plus 2 gives me what? 9, and 9 plus 5 equal to 14. I cannot write 14, and I have to subtract 8 from it. And if I subtract, what do I get? I get 6. So I write 6 here. And as I subtracted it for once, my carry is 1, and carry will come to the lower position, and this 1 plus 5 equal to 6, 6 plus 4 equal to 10, 10 plus 7 equal to 17. Once again, I'm not allowed to write 17 just because of 17 is not present in an octal number system. I subtract 8 from this, and if I subtract 8 from this, what do I get? Can you tell me?
9.
9. Okay, but can I write 9 here?
9.
9 is also absent in octal number system, so I have to subtract once again until I get the digits of octal number system. I have to subtract, so I have to subtract until I get the digits of octal number system, as I am doing the addition in octal. So if I subtract it, I get 1, but in here there is a problem. I didn't subtract it for once, I subtracted it for twice, 2 times, these 2 times. So carry is what? My carry is what? My carry is 1 or 2. Shabash, carry is 2. Great. So this 2 will be added here and place here as like, but this shouldn't write on your copy. Is for your understanding, just for your understanding. And 3 plus 2 equal to what? 5. And 5 plus 6 equal to what? 11. So 11 is here, but 11 is not allowed in octal. I have to subtract 8 from it. I get 3, and 3 is here. But this 2 plus 3 equal to 5, 5 plus 1 equal to 5 plus 6 equal to 11, 11, and subtract 8 from the 11, and then I get 3. But as I subtracted it for once, this 1 is my carry. Where is the 1, man? This 1 is here. So answer is 1316. Clear, sir?
Yes, sir.
Okay, sir. So you said it correct, but there is something is missing here. This 1 is missing here. If you could say 1316, it could be right. Okay, so I think now you understand that how to do the addition and what is the procedure and proper procedure. Now I'm going for an hexadecimal addition. For an hexadecimal addition, let's see how do you do this. Hexadecimal. In hexadecimal, I know this, and you also know the base is 16. In hexadecimal, base is what, man? The base is 16. So I have to subtract 16 if I do not get the digits from 0 to f, and f means 15. In hexadecimal, I know this. I know that you also know that from 0 to 9 there are 10 digits, and after 9 there is no 10. There is no existence of 10. We have a, and a for what? 10. And gradually this going that this one, the f means what? 15. f means what? क्या होता है? 15 होता है. बुझता है और नहीं बुझता है, मुझे बताओ. So ये तो हेक्साडेसिमल का मामला होता है. तो हेक्साडेसिमल का बात क्या क्या सुनता है, क्या क्या जानता है? a for what? 10, and f for 15. So we do a simple addition in hexadecimal, then we can understand that what's going inside the hexadecimal addition. In hexadecimal, what we can say or what we can add. Suppose we are adding this number Baba to BD. My Baba is my father is from Bangladesh. We want to add this 2 number. We want to add this 2 number in hexadecimal, and you can write this as your rough if you cannot recall that what D stands for and what A stands for. Sir, can you tell me what D stands for? D means what in decimal? 13. Fantastic, you rock. Okay, so when you add A means 10 to 13, you get what? As a rough we can write, you get what? 23. Okay, fine. But 23 हेक्साडेसिमल का डिजिट नहीं होता तो क्या करता है? इसका साथ क्या वियोग करता है? 16 वियोग करता है. किस लिए? cos 16 हेक्साडेसिमल का बेस होता है. सो ये तुम हेक्साडेसिमल का डिजिट नहीं पाता है तो क्या करता है? बेस वियोग करता है. हेक्साडेसिमल का बेस क्या होता है? 16 होता है. तो 16 वियोग कर दो, तुम्हारा काम खत्म होता है. तो if we subtract these, what do we get?
7.
7. Fantastic. The 7 is my result or sum. But as I subtract it for once, as I subtract it for once, this 1 is my carry, and 1 will never be lost. 1 will come to this B. is saying that B, please accept me, I do not want to be lost, please accept me, please take me in your consideration. And then B will accept it. Okay, don't go anywhere, I will accept you, I will grab you in my life, I will never let you go alone. So B is added to 1, that gives me B is actually what? B means 11.
11.
Believe is 11. 11 plus 1 equal to 12. And 12 plus 11 क्या होता है? 23 होता है. Okay बच्चों? 23.
जी सर.
Once again 23. Wow, it's magical.
Yes,
It seems very magical. And 23, I subtract 16 from this. Once again I get 7. I write this 7 as my sum. And as I subtracted it for once, this 1 is my carry, and this 1 will never be lost. This 1 will never be lost. This 1 will come to this, and he will tell this A that please accept me. A will say that okay, I will accept you, do not go anywhere. This A will gradually actually really accept this A1, and this A means 10 and 1 means, so A added to 1 is gives me actually what? B, 11. 11 means B. We do not write 11, we write B. So B is present
B.
in hexadecimal. So we write this. We do not need to do any kind of subtraction here. And as there is no need of subtraction, that means we have carry or not. Do we have carry here? Do we have
No,
carry?
sir.
No carry. There is no carry. So कोई भी झमेला नहीं होता है. ये B का आता है तो मेरे पास कोई भी झमेला नहीं आता है. तो मुझे तो सिंगल थकना चाहता है, मुझे सिंगल है. मेरे पास कोई मालूम नहीं होता है. तो B क्या करता है? मुझे सिंगल होता है तो होता है. B बढ़ जाएगा. B একা একাই ছিল সারা জীবন. বুঝছেন? তাহলে এটা হচ্ছে আমাদের आंसर. স্যার বুঝে যাচ্ছেন নাকি বুঝেন নাই?
বুঝেছি স্যার.
Okay sir, তাহলে আমি এখন আপনাকে এটা I will give you 1 2 for your exercise and you will tell me the answer. What can I give you for your exercise? I can give you this one. Okay, wait. Okay, so I can give you this, the cafe. So do you think that cafe is good for good or bad? What do you think?
Bad.
Why bad? Because it gives us so many unhealthy foods but pleasant foods. Okay, so many unhealthy foods are served there. Okay, so what can I do? We write actually cafe and we say that this is bad. This is bad for our human body. So can you do the addition and let me know the answer? After that I will resume.
9B.
Is CBB 9B? You say CBB 9B. I think you're right, and exactly you got it right, sir. Is CBB 9B? So we can do a fast addition here. So D means actually 13 and 13 plus E meant 14. 13 plus 14 equal to gives me what? So 27. So 27. If I subtract 16 from here, what do I get, sir?
11.
11. So 11 is actually this hexadecimal number system. We write 11 means B. 11 means क्या होता है? मुझे जानना चाहता है. 11 means B होता है. As I subtracted it for once, this 1 is my carry, will be added here, and 1 will be added to 10. 10 means 11, and 11 plus E is equal to what? 14. 14 তাহলে এটা হচ্ছে 25. So 25, if I subtract 16 from 25, it gives me 9. Okay, so 9 is added here, 9 is written here. This 1 is my carry just because of I subtracted it for once. And this B plus 1 equal to 12. 12 and F means 15. Then it gives me 27. So 27, that means this process once again. 27 means I get B as my addition result, and 1 is my carry. This B, A and 1 equal to B, and C is placed here just because of there is nothing to add. And these, the round shape numbers, is not necessary to write. You have to write them. I have written just for your understanding, nothing else. Okay sir, আশা করি বুঝতে হয়. Okay, this is the answer. So is this seems easier or not?
easier.
I think this is the easier process. So you do not need to memorize anything. You do not need to be panicked or depressed or hopeless that I do not know how to do the addition in number system. So this is all about the addition in number system. But problem is that we can get any point numbers or any number with radix points or any point and fractional numbers, and they can say us to add the numbers. And how do we do this? I give you one example, and this one example can be actually applicable to each and every number system. So I give you once for your understanding. I start with a binary number, two binary number which you have to add, or we have to add. This one is, suppose see, you are asked in the exam hall that to add the numbers like 101.01 plus 110.1. Okay, there are two numbers which are in binary number system. How do you understand? By seeing their subscript. This is in 2, after the bracket there is a subscript, and this is a subscript. You see that this is written 2, that means this is in binary number system. So if you want to add them, you may find it tough to that how to add the numbers as they are in fractional numbers. So I give you idea about this. 1101.01. This point is radix point. In each and every number system there is a point, and this point, whether you see the point, this point has a common name, and this common name is radix point. You see that there is imbalance. There are 4 digits before the radix point, and there are 3 digits before the radix point. There are 2 digits after the radix point, and there are 1 digits after the radix point. So how can you do this? Let's see. I write 110. Okay, 110. How to write this? 110 and 0.1. Okay, clear hota hai sir?
Yes, sir.
This is the process. So here the tough point is that position. Okay, if you see that position from for any actually whole part, this is a whole part and this is a fractional part. For whole part you start setting the numbers from right to left. So 0 is placed here, 1 is placed here, 1 is placed here. This there is this place is vacant, there is nothing. And for the point parts or fractional parts, you have to start from right to left. This 1 is here, this there is vacancy, okay. So can you do the addition now? Can you do the addition now, sir?
Yes, sir.
I think you can.
Try করে দেখি।
Please, sir. What's the answer? So once again, what's the answer?
1001.11.
Okay, fantastic. I think you got it right. I do
100.
Okay, sir. Thank you, sir. I check it for once that whether it is correct or not. This one will be placed here as there is nothing to add. This one will come to this one and say that please add me. This 1 plus 0 equal to 1, and as there is a point, you also set the point here. That's the radix point. 1 plus 0 equal to 1. 1 plus 0 equal to 1. This is very easy calculation. Okay, and 1 plus 1 equal to, here is actually tricky part. 1 plus 1 equal to, I write it in my rough part, that's 2, but I cannot write 2 just because of 2 doesn't exist in binary number system. I have to subtract 2 from this 2. I get a big 0. This 0 is placed here. As I subtracted it for once, I get 1 as my carry. This 1 will come here and will ask 1, please accept me in your life. I do not want to be single, I want to add with you, please accept me. This 1 will say that yes, I will accept you, do not go, please stay with me. And this 1 will be added to this one, and it gives all once again a 0 just because of this process. You see that this process, follow my cursor, and as it gives a carry 1, this 1 will be placed here. This is the answer. Okay, sir, is it easy? I think you have no problem regarding this whole addition, whole numbers addition, and fractional numbers or addition of numbers which has radix point also. So I think this will be very much easier for you to solve any mathematics, whether it's tough or easy. Now this addition part is done. We can conclude this one. and we can go for what? We can go for binary. Now we can go for actually subtraction, though subtraction is not that much important for your creative question, but it can actually help you to solve any MCQ answers. You will find some MCQ type questions, and there you will be needed the help of subtraction. So subtraction is a slight bit complex comparing to this one, but I will make it easier to you as I'm teaching in very easy method. I will never let you understand anything in hard or in tough method. Let's see what subtraction is and how to do this. So addition part is done, we are going to subtraction part. Okay, now our topic is subtraction. Okay, subtraction, first of all I want to start with the decimal, which is very known to us, and we are doing this from our childhood. Decimal number system subtraction. How do we do this? Let's see. I write a number 1 and 7, and I write 9, and I write, suppose here suppose this is the number, এটা subtraction করতে বলছে। Okay, আচ্ছা, so you see that at the higher position the number is 7, at the lower position number is 9. So can we subtract 7 from 9? Can we subtract? Is this possible? This is not possible. Actually this is not possible. As this is not possible, because we cannot subtract any lower number, we cannot subtract any higher number from the lower number. So as you see that 7 is lower comparing to 9, so we cannot subtract it. As we cannot subtract it, we do a tricky part. Here. And what's the tricky part? The tricky part is that we add 1 to this. Not actually 1, we add 10. Why do we add 10 to this number, to this higher number? Because
base of the
base, yes, because base of the decimal is 10. So 10 added to 7 gives me 17. Now is it higher than 9? Is it higher than 9? Yes. So can we do the subtraction? Yes, we can do the subtraction. So if we do the subtraction, what's the result of this subtraction? Can you tell me?
8.
8. Fantastic, you're very fast. So 8 is written here. So as I already have introduced you self with a carry, with the concept carry, so you also understand what carry is. But this one actually, this addition, look at this subtraction. This subtraction was not possible. To make it possible, we borrowed the base of the number system decimal here. We borrowed the base of the number system decimal. So decimal was borrowed here, and we used it for our subtraction. We wrote the result. But as we borrowed decimal, as our subtraction purpose, this 10 was used here. Now this 10 will come at the lower position here. You see what I am doing? This 10 will come here. Here 1. This 1 will come here. I mean I want to erase this. This 1 will come here. So this 1 is here. Okay, why do we need to write 1 is here? This is for understanding. You do not write the YOLO part, YOLO letters. What do I write? Do not need to write the YOLO part in the exam hall. So this 1 is actually here, coming back here, just because of I have borrowed 10 to do the subtraction, and as my subtraction is done, this 10 will come here. But when this 10 comes to the 7, it was powerful, but when it backs to its x, it becomes valueless once again, and the value is 1. So when you go with someone, they treat you very bad, they treat you very good, and they give you value for a very short time. But when you back to your actually past, or the person with whom you actually used to stay, they do not treat you like they are like the before, just because of you left them and you have chosen another one, and you have come back to the person just because of they treat you like 1. And when you are with another person, you are treated like a princess. And when you back to your past life, then you are treated like 1, very simple. So this 1 and upper position, this is 1. If I subtract 1 from 1, what's the result?
1 from 1, 0.
0. So this is the answer. Okay, so in short, what I can say, if you cannot subtract the number, if you cannot subtract in this position, then you have to borrow the base of the number system. The base of the number system is 10. I borrowed 10, and 10 plus 7 equal to 17. I subtracted 8, and as I have borrowed the base of the number system, this 1 will be added at the lower position. Okay, and then I do the subtraction. So this is the process. I give you one example, I'll give you another example in binary number system, then you can understand. This is subtraction. This is a slight bit different process. You observe it properly, you can understand. I write 1 0 0 1 1 1 1. Okay, I do the subtraction. Let's see what happens. 1 minus 1 gives me what?
0.
0. When I try to subtract 0 from 1, is it possible? Is it allowed in mathematics? No. So I have to borrow which? What? 2. Cause I am doing this subtraction in binary number system. So here 2 will be added to 0, and that gives me 2, and 2 minus 1 is equal to what?
2 minus 1 equal to 1.
1. Okay, fine. So as I have borrowed 2, that means this at the lower position I have to add 1 to this lower value. So 1 and 1 will be plus and will be added, and that gives me 2. But at the upper position it's what? 0. So can I subtract
0.
2 from 0?
No, sir.
No. So I have to borrow what? The base of the binary, that means 2. Now I can subtract 2 from 2, gives me what?
0.
0. As I have borrowed the base of the number system, I have to add 1 at the lower position, this 1, and 1 minus 1 equal to what? 0. I write 0. Okay, this is the process. Actually, though subtraction is tough if you follow other processes, but this process is the simplest process and the easiest process, you have to believe. So is it tough or easy to you? Are you getting it or not?
It's easy.
It's easy. This process is the easiest process in this whole universe, so no one can offer you any other easier process than this. Okay, now I go for another addition, then I will give you one for exercise. Let's see what I do. Okay, octal. Now I go for octal subtraction. In octal subtraction, I write a number at lies 4 5 2 7 6. Okay, let's see how do we do the subtraction in octal number system. So 2 minus 7 is not possible. I have to borrow what? 8. I have to add this 8 to the higher value, and 8 plus 2 equal to what? 10. So now I have to subtract 7 from 10. It gives me what, sir? It gives me 3. I write 3 here. So as I have borrowed the base of the number system, I have to add 1 to the lower position. Okay, 1 plus 7 equal to 1 plus 6 equal to 7. So at the lower position the value is what? 6 or 7? Right now 7. 7, but this is 5, so this subtraction is not possible. Mathematics doesn't allow this, so I have to borrow what? The base of number system, the base of octal number system, this is 8. Now I can subtract 8 and 7. I can subtract 7 from 8, it gives me 1. This 1 is my result, and as I have borrowed the base of the number system, for this 1 will be placed here, and now I have to subtract 1 from 4, which gives me 3. This is the result. Okay, as I have written the numbers in red color, you do not need to write them in your on your copy, so you can skip this. I just write this for your understanding. You do not need to write this in your on your copy, so you can avoid them. Okay, now I give you one for your exercise. Let's see, what do I give you? Basically in octal number system you will do the subtraction and will let me know the answer. Okay, do this and let me know the answer. Okay, you said that 663, right? Let me check it, the answer. 2 minus 7 is not possible. I have to borrow 8 as I'm doing the subtraction in octal number system. 8 plus 2 equal to 7. 7 minus 8 plus 2 equal to 10. 10 minus 3 is equal to 3. And as I actually borrowed base, I have to write 1 at the lower with the lower value. Add 1 to 6 gives me 7. 5 it's not possible. I add 8. 8 plus 5 equal to 13. So 13 minus 7 gives me 6. Okay, fantastic. I write 1 just because of I have borrowed 8, and that means 7 minus 1 equal to 6. Fantastic, you got it. You have done it perfectly. So now if I give you one subtraction which is in hexadecimal, will you be able to do this? I give you one. Okay, I am giving this to you for your exercise purpose, and we are doing this in hexadecimal. Okay, so can you give me a suggestion, actually a feedback, that which color looks actually more convenient to you, red, blue or white? Which color is eye soothing, and you can clearly understand the words that I write?
All of them are okay, I guess.
Okay, yellow should be
You can
avoided.
understand.
Yellow should be avoided. Okay, ठीक है, that's okay. So I give you a number like okay, do this subtraction and let me know the answer. The answer is, you say 609.
69.
639. Okay, sir, I got it wrong. 639.
C, sir, C.
Oh, sorry.
12.
C39. তাই না sir? Is it?
No, 6, C, 9.
Okay, once again I'm getting this 6 C9. Okay, let's see. 8 means what? 8 and then what will be added? 16 will be added as the base of size 16. 16 plus 8 gives me what? 24. 24 minus 16 gives me what? 8 or what?
24 minus 15. Sir?
Okay, fine, fantastic. Okay, 15, cause hexadecimal, in hexadecimal f means what? 15. So if we subtract 15 from 24 gives me what? 9. So 9 is written here. Fantastic. This 1 will be added just because of I have borrowed the base, and 1 plus e, this 1 also, every time, remember, every time this 1 will be added to the lower value, not add to the higher value. You must remember this. This 1 plus e equal to what? At the lower position we get e means 14 and this is 15, and b means what? 11, and 11, this is 26. Okay, by adding two number we get 26, and 26. Okay, what do I do? What are we doing actually? So see, actually at the lower position number is 15. Okay, and at the higher position, this is b means what? 11. B means 11. So we cannot do the subtraction, so we add 16 to the value 11. So 16 and 11 gives me what? 27. Okay, so if I subtract 15 from 27 gives me 12, but I cannot write 12 just because of 12 is presented by c, and c is written. This 1 will be placed here, and 1 at so if I subtract 1 from 7 I get 6. So your answer is absolutely right. Okay, sir, thank you, sir, for your correct answer. Okay, we have talked about addition and subtraction. Now it's time for another part, and this is the coding system. In computer there are different coding systems, we know this, and this is actually one of them is binary. So binary is a code just because of we human do not understand them. we only work with a single number system. And which number system is it?
Binary.
Do we work with binary or we work with decimal?
Oh, a human হিসেবে decimal.
As a human, we work with decimal number system. And if I can give you a very short idea about what code is, if I can give you a very short idea what code is, I will definitely tell you that. Let's see, I will tell you that. Wait, okay, what code is, I will tell you. So code means anything without decimal. Just remember this one thing, just remember this one thing, anything without what? Decimal. So anything without decimal is called code. Okay, I repeat, anything without decimal is called code. So if I tell you that is binary is a code, binary is also code. Okay, is octal is a code, octal is also code. So we human work with decimal number system, and without this number system everything is code. And we also know that what binary is, and binary is made up of only 2 digits, and these 2 digits are 0 and 1. And different types of codes, these are which are in HSC level syllabus. I want to discuss about these topics, that codes are basically 2 types. So codes, if I consider this code, one is simply BCD code. One is what? BCD code. BCD is binary coded decimal. I will elaborate this after a few moments. And one is alphanumeric code. Alphanumeric code. Alpha. What is alpha? I will also elaborate this. I will elaborate. Don't be panicked. Alphanumeric code. So alphanumeric codes are of 3 types. One is ASCII. I think you have heard their name. ASCII, and is EBCD. And the last one is what? Can you tell me? The most renowned, the most used coding system that we are using to write anything in our mother tongue, that if we write anything in Bangla, it will be translated into computer's language binary using this coding system, and this is Unicode. Okay, so Unicode, EBCD and ASCII. Why are they called alphanumeric? Just because of ASCII includes English letters also. ASCII includes what? English letters and different kind of symbols, and key symbols. EBCD also same, it also includes English and different kind of symbols. But Unicode is quite different here. Suppose but not suppose, we do it really, and every time we write A, B, C, D, and we also write Shoreo, Shorea in Bangla, and in Urdu there are some other symbols. So in this, around this world there are different type of language, a huge number of languages exist in this world. So but computers, what about computers? Do computers understand Bangla? Do computers understand Urdu or Hindi or other languages? Do computers understand? No. So you write something in Bangla, suppose Amar Bangladesh, so you understand this, and the person you want to send the message, he or she also understands this. But the problem is the intermediate media which are being used to transfer this message from you to the other person. This machine, this computer, this PC, this mobile, this laptop doesn't understand this Bangla, Urdu, Arabic, Farsi. So this Arabic or this Bangla or this Urdu have to be transferred in a language, and this is a binary language. And the system is working behind it. Is Unicode. So Unicode is actually coding system. If you write Shoreo, there are some fixed binary digits generated for Shoreo. If you type Shoreo or Shorea or Ko or Kho, computer, it will automatically be generated some binary code, and by which computer can understand this. It is typed shoreo, you have typed shoreo, or you have typed alif, or you have typed ba, ta, sa, the Arabic letters, the Arabic symbols. So do you understand what Unicode is? So Unicode is an intermediate media, a coding system which transfers our mother tongue to which number system?
Binary.
Binary. For what? For what?
For I don't know.
Just because of computers do not understand Bangla or Urdu or Arabic or Farsi, okay, so it has to be transferred into computers language, and computers understand binary. So this coding system will do what? Will convert each and every language, each and every different type of languages to binary number system. Okay, clear hota hai sir?
Sir.
Okay.
Yes, sir.
Okay, so this is called actually encoding. Encoding means all of the languages will be converted into computers language. This will be encoded. But when this language should be visible, should be displayed to our receiver's end, it will definitely be in the format that you sent, that you have sent, and then it will be another time it will be generated into human language, and that process is called decoded. So there is two process which is working every time you send a message, and the person you send, he receives the message. There is encoding and decoding. So there is actually two concept. One is what? Encoding. Okay बच्चों, क्या होता है? Encoding होता है, and another क्या होता है? Decoding होता है. So encoding and decoding का मामला क्या होता है? Encoding का बात होता है another language का human कंप्यूटर का लैंग्वेज का ट्रांसफ़र करता है. डिकोडिंग का बात क्या करता है? ये कंप्यूटर का लैंग्वेज का ट्रांसफ़र तो करता है, बट when you want to send the message to the receiver, he will never understand binary language. So this binary language once again has to be transferred to human language, and this process is called decoding.
Yes, sir.
Okay, so there is two process which is working simultaneously. One is encoding and another one is decoding. I hope you understand. Okay, now I'm going to the discussion that what BCD code is and how to represent this BCD code. And see, I redirect you to a PDF file, and PDF file is here. Okay, you see a PDF file. Okay, you see a PDF file. So here you see that different types of coding system, different type of coding system. Which are the coding system? You see the different type of coding system. They are actually BCD code and alphanumeric code. So alphanumeric codes are that type of codes that also added the alphabets or ABCD or the Arabic alphabets or Bangla alphabets. BCD code is a special code which doesn't include any kind of letters, any kind of letters. It can be English, it can be Bangla. It only works with decimal digits. It only works with decimal digits. So how do we write any BCD code? I'm giving you example. BCD is important for your exam. Let's see it carefully. So in BCD actually we work with decimal digits. We work with what? Decimal digits. How many decimal digits are there? Can you tell me?
9.
9 decimal digits, from 0 to 9. From 0 to 9. So suppose I write a number at least 472. So how many digits are there? There are 3 digits, and for each and every digits, for each and every digit 4 binary bits will be written. I repeat, for each and every decimal digits from 0 to 9, 4 binary digits will be written, and this process is called BCD. This process is called BCD. If you see the example or if you see the definition, you can understand this. Let's see, in this code each decimal digit is represented by a 4-bit binary number. Okay, so BCD is a way to express each of the decimal digits with a binary code. In the BCD with 4 bits we can represent 16 numbers from 0 to, okay, I'm giving you the idea. Let's see. So can you recall the magic number? This is 8421. 8421. Okay, so using this 8421 I have to write 4 binary digits for each and every decimal digits. if I work with 2 first, then what do I get? The binary of 2 in 4 digits will be, this 2 will be added for making this binary of 2, this, so I write 1 underneath the 2, and rest of the bits, rest of the digits will be 0. So what is the binary of 2? The binary of 2 is 0010. Okay, 0010. Okay, now it comes to 7, and what is the binary of 7? What is the binary of 7? If I want to write 4, 2 and 1, because 4, 2 and 1, because these 3 digits are needed to make the number 7, and this 8 is useless, we do not use them to make 7, this is 0. And what about 4? To make 4 we need only this digit 4, we need only this digit 4, so under this digit this will be 1, that means this digit is used, this digit is used, that means we need to write 1 underneath the number, and rest of the digits are not used, and we write them 0. 0 means they are not used. So what is the 4 digit binary number of 4? This is 0 1 0 0. Oh, I didn't write the 4 digit number of 7 mistakenly. This is 0 1 1 1. So do you understand how to find BCD of any number? Do you understand, sir?
Yes, sir.
So BCD means I write 4 binary digits for each and every decimal digit. Shesh. That's it. So BCD means binary coded decimal. Tar mane, what does it mean? So each and every decimal digit actually are coded with 4 binary bits. That means for each and every decimal digit I have to write 4 binary digit. So this is called BCD. So if you are asked to write any numbers BCD, you will be able. So this is very simple process, don't need to be worried about this. So in normal process we use the number 8421. It also can be other forms, but 8421 is mostly used BCD. Okay, we go to the slide. So here you see that from 0 of BCD of 0 is 4 zeros, BCD of 9 is 1001. How do you get this? Using the magic number 8421. Okay. Okay, let's see advantage. We need to remember binary equivalent of decimal numbers 0 to 9 only. Okay, this is not important. Different types of BCD is available, but as I told you that 8421 is mostly used, and this is very common. You do not need to understand them or memorize them. So if the BCD is 7421, that means in here the magic number will be 7421, not 8421. Okay, here will be placed 7. Here will be placed 7. So considering this 7, you have to find the binary. This will be, I think, exactly the same. Okay.
7 কেন?
This can be, এই যে এখানে দেখেন যে BCD অনেকগুলো কোডের হতে পারে, 8421 হতে পারে, আলাদা আলাদা অনেকগুলো কোডের হতে পারে। যদি BCDটা 8421 হয় তাহলে আমি এভাবে করব। সাপোজ BCD is 7421, কোশ্চেনে বলে দিল BCD is 7421, তাহলে আমরা এটা কিভাবে করব? 7421 এর জন্য একটা করে দেখাই, তাহলে it will be easier for you. সাপোজ আমি একটা নাম্বার লিখলাম 927, তো 7421 যদি BCDটা ইউজ হয় তাহলে আমাদের ম্যাজিক নাম্বার তখন কি হবে? 7421. ওকে, আচ্ছা, let's see what is the binary of 7 in 4 bits? 1000. So I write 1000. What is the binary of 2? 0010. Then it will be 0010. What is the binary of 9? It will be this 7, 2 will be used. This 1 1 and 0 0. Then it will be 1010. Is it clear now, sir?
Yes, sir.
So this can be any other in any other format. It can be 7421, 5421. This number will be used, but 8421 is used, and 8421 others are not used actually. So you do not need to think about others. Now this is the process, that here is a number 592 and it's converted to BCD. Can you find the number BCD of 807? You do this, please tell me, and the answer, the binary, the BCD of 807.
Is in which format? 8421?
8421. If you are not set, if you are not asked any format, you have to use 84. Fantastic. Okay, you got it right. Okay, now we can talk about alphanumeric codes. Alphanumeric codes are basically 3 types. One is EBCD. You can actually memorize the full form. This is very important for your question, and this ASCII is very important. You also have faced this question in all of your exams, I think, that ASCII. What is the full form of ASCII? This is American Standard Code for Information Interchange. You must remember the whole name. You cannot do any mistake writing this name, because this is the full form. This has to be the exact. Okay. Unicode means universal code. So you can ask the you can be asked this question, that which number system is used currently to convert any number, any mother tongue to binary. Which number system is used, widely used? Unicode. So Unicode is the only number system which converts any other mother tongue. It can be Urdu, Hebrew, Farsi, Tamil, any other mother tongue to binary. So this is Unicode. And EBCD is not that much used right now. ASCII is used and Unicode is used. EBCD is a coding system that was invented by IBM, but this is not that much popular right now. ASCII is popular and Unicode is popular, and we will be talking about this. So EBCD, you do not need to remember a lot of things about this, because these will never be important for your CQ questions. These are only important for MCQ questions. What will be needed for this question? You just see that what do we do. You just need to remember this thing, that Unicode is what? Extended binary coded decimal interchange code. You just need to remember the full form. I repeat, extended binary coded decimal interchange code, and it's a 8-bit binary code. You just remember two things, that's enough. Nothing more will be needed, and it was used by IBM, a computer company. Now we go for ASCII. This is important. ASCII is very important. So ASCII, you also need to remember the things, that full form of ASCII, American Standard Code for Information Interchange. It can be of two types, ASCII 7 and ASCII 8. ASCII 8 is mostly used. ASCII 8 is mostly used. Okay, you just need to remember these things, and that will be needed. Nothing more will be needed from here. This is only for MCQ purpose. Now we go for Unicode. And Unicode is what? Unicode is actually stands for representing characters as integers. Unlike ASCII, Unicode has 7 or 8 bits for each character. Unicode uses 16. This is important. Unicode is 16 bits code. 16 bits. You have to remember this. That's 16 bit. Okay. Unicode is 16 bits. And which mean it can represent more than 65,500 number. So how does it come? How do we get this? We get this by actually power system, 2 to the power 16. If you do the calculation, you get what? Can you tell me the answer?
2 power 16.
This has gotten from by this.
6 5.
And this is the most important part. You see that this is a bit of overall for English and Western European languages, but it is necessary for some other languages such as Greek, Chinese, Japanese. Many analysts believe that the software industry becomes increasingly global. Unicode will eventually support ASCII as the standard character coding format. So ASCII is of 8 bits basically, and Unicode is of 16 bits. Okay, so this is all about our lesson. Now we go for some questions. So what is code? Can you tell me?
Anything but decimal
Code.
code is
Fantastic. Okay. Acha, this is very important. You also have faced these questions many times. Can you recall this question? Which one of the equivalent BCD code and binary numbers of 15 takes more bit? Which one takes more bit, BCD or binary? BCD. Cause if we find the BCD, if we find the BCD of this number, 15, then it will be what? 4 digits for 5 and 4 digits for 1. Okay, using 8421. But if we find the then there will be how many digits? 8 digits for BCD, but for binary, remember this can be matter of confusion to you. But for binary, how to find the binary of 15? Can you tell me what's the process? Then I will think that you have gotten the perfect idea about this. So BCD of 15 is 4 bits for 1 and 4 bits for 5. But what is the binary of 15? How do we find this? Can you tell me?
I'm not sure cause there isn't like any other basis.
Okay, I will make it clear. To find any numbers binary, we have to use a magic number. We already told you 8421. Can you recall this?
Yes, sir.
So okay, what is the binary of 15? 1 1 1 1. All of the digits are used to make the binary of 15. So this is the binary of 15. It takes only 4 bits. But to make the BCD of 15, what do we need? BCD এর জন্য কি লাগবে? 8421 করে ফার্স্টে 1 এরটা বের করা লাগবে, রাইট? 1 এর কত হবে? 0001. Then what is about 15? What is about 15? Sorry, what is about 5? What is about 5?
5.
1
0 1 0.
1. Then it will be what? I am writing just because of your understanding. 0 1 0 1. And what is for 1? 0 0 0 1. So you see the difference. Do you understand, or you have confusion after this?
No, sir, I understood.
Thank you. So binary means use a single magic number 8421, and you consider this number, and when you talk about BCD, you consider the digits separately. Okay, I'm saying you for several times just because of you remove all of your confusions regarding this. Okay, fine. Now I just go for 1 or 2 MCQ, then I will end the session for today. Okay, tell me, which one is 8-bit code? Number 1. Answer me the question number 1.
BCD.
BCD and EBCD.
All of them. No, what about ASCII?
What about ASCII?
Nine.
ASCII is of 8 bits. EBCD is of 8 bits. But BCD is BCD of 8 bits? No, BCD has 4 bits. 4 bits binary for each and every digit. So what's the correct answer? A, B, C, or D?
AB.
1 and 2 is correct. 1 and 2 is correct. So what will be correct? This one. Okay,
Yes, sir.
this one. Thank you very much. So this one is correct. Okay, what about this? Which type of code is used to include Bangla language in computer? This one?
Unicode.
Unicode. Fantastic. All English letters can be included in microcomputer with which coding system? English letter.
Unicode.
Unicode, EBCD, and ASCII.
All of the above.
These 3 are used for English letters. For other languages, Bangla, Urdu, Farsi, only Unicode is used. Okay, for other languages only Unicode is used, but English is covered in all of the coding system, in alphanumeric coding system. Okay, sir? The last one, how many bits are in ASCII?
8.
Okay, this is the end of our today's